Right, well, I'm back again, doing a bit more on the old carbon fibre. Something I found that might be of interest is, as you can see, we've got, I think you can see it, we've got about 339, 340. I'm not sure if that's going to make any difference. 343. Just see if I can get that to stand. Now, as I raise the carbon fibre out of the water to about that position, it starts to increase rather rapidly. And I'm not sure why. And yet the amperage remains exactly the same, even though the surface area is far less. Getting 371. Yeah, and that's continuously going up. But that was just a side thing. I wanted to show what we could do with just carbon fibre and the metal. And so I'll take this out of the way. Put that over here. Just out of the way. I'll leave that. My wife has decided that she's going to come along and bugger about. Would you like to be on camera, sweetheart? Okay, so what I've got here is carbon fibre and a piece of aluminium, and that's right in the way. And I have a capacitor and a joule thief. I forgot to mention that in the previous video, and I can't leave that on there because I need my leads. So unfortunately I'm going to have to take that one off for the time being, and connect these leads up to the capacitor. Just move that out of the way. Move that out of the way since we're not using it. I'm not sure if I can get that in there, but so the green is positive. We'll connect that up to the positive of the joule thief, which is always a good idea. And we'll connect negative. Hopefully something should happen. See if I can get my hand out of the way. Nothing. Typical. So I'll just check what's happening on that. Maybe I've hooked it up the wrong way like an idiot. Yes, I think I have. Have I? Yep, I have. So let's now put that on there. I hope you saw that flash. Takes time for it to build back up, but it's usually a pretty bright flash. And this is capacitor is this? .25 volts, 1000 farad capacitor. And that's no longer building up. That's just typical. But that was a piece of aluminium. And so we'll try a different metal. I'll simply take out the aluminium. It's very old aluminium. And we will try a piece of stainless steel. And we shall simply pop that stainless steel into there. Immediately a flash. Again, that's come down. Not sure why that's happening. Still.
You haven't got that with me. Oh, I get that off.
Now we'll try with magnesium.
Ooh, that one's not.
And immediately straight on. Well, at least one thing's been successful. On camera. Where's my clamp? There it is. And as you may be able to see, that's reasonably bright. That's a good idea, thanks. Let's take that one off. And that's just a piece of carbon fibre and magnesium. Hope you can see that. You can actually do this with stainless steel. I'm not sure why it stopped working. Let's just try again. Put some light on. Thank you. And there we go. Just turn the light on. You may be able to see it is lit. It's not very bright, but nevertheless it is lit. But obviously magnesium is far better. Gives a lot more amps. I have this, which is magnesium that I bought off the internet. I've cleaned it up a bit. It's 99.99% pure. However, it is not as good as magnesium ribbon, but it does the job. It lights. Just let me clamp that in. As you can see, it's fully lit. No, just my connections not brilliant. So I'm using a breadboard, so nothing's absolutely tight, but still. Now normally you would say two dissimilar metals would give a galvanic reaction. We're not using two metals, we're using a single metal and carbon fibre. So why that should light in the way in which it does, now you need to move the link right over there. So why that should light in the way it does, I'm not 100% sure. Is there enough?
It's alright, I'll just leave it there.
Okay. And that's really the end of this. If you've got any comments, suggestions, I'd be quite happy to take them on board. Yes, of course, if anybody bothers watching this. And thank you very much. Has it stopped?